Hello, Mike.
Hello, Honkai. How was your holiday?
Yeah, good.
Good.
Thank you. Peter.
This is a great turnout.
Oh, wow. Yeah, there's a lot of pages I'm scrolling through.
Yeah, this is great.
And a pleasure, as always, to have both leads, too.
Stop sucking up. Anyway, more seriously, welcome everybody to the May 6th SIG Multicluster call. And we have a few items on the agenda. Corentin, you're up first.
Hey, I just wanted to do this quickly. Sorry, I hijacked the high of the list. I wanted to know if we could go maybe like some statuses of little projects that we've been talking about before we deep dive into discussions. If that's okay, I'll dive quick on two things I've been looking into. One is the hub cluster PR like definition. Rainbow Mango, you got some comments, and you'll address that to with Federation folks. So I'm looking forward to the discussion. You can invite me, or please get some notes. And the other thing is I'm adding more notes for credentials for the plugging for cluster profile. And that's it for me. But if we want to go quickly, like Laura, maybe for APAC.
Yeah. Am I talking? Yes, I am talking. Yeah, no updates regarding the APAC meeting. We talked about it last week and briefly in the SIG, and then there's a long Slack thread. I know some people who are on the call are interested. I did talk to Jeremy about it a little bit, but I haven't gotten a chance to talk to Stephen about it. So I'll circle with you, Stephen. We want to talk to you in particular now that you're back from PTO, and then I'll update again. Next.
Ryan, maybe on the.
Yeah, is Mike or Ryan in the call right now? We would like to hear just a status on cluster profile properties from Ryan or the MCS versioning conversation from Mike, if you can give the briefest.
I think for the cluster profile one, actually, Corentin is the one that is driving this, but most of the action is from his side. But we are looking at the plugging model, and I don't have any progress to report, but we are definitely driving towards that goal. Hopefully, we can get some conclusion or get some first draft out by end of this month. And the MCS one is, yeah, I think Bobby has a hands up.
For MCS, oh yeah, I see.
I see your lips moving, but I can't hear anything. And hard mute because I don't see muted in the call.
No, cannot hear you.
Can you hear me now?
Working now.
Yeah. I just wanted to give a quick update. You know, Corentin, you have this hub cluster cap out there, right? So I actually checked with Jeremy, and he said that this is fine with him. I just wanted to bring it up with the whole community right now. If you have any concern or objections, please raise them now. Otherwise, we assume in a couple of days or so, we assume that SIG leads can go ahead and approve that PR. That's related to cluster profile, but one other area, you know, like cluster properties, I think one of the other areas that should be our focus is adding credentials for cluster access to cluster profile. You know, Ryan and Corentin, both of you, I guess, are aware of that. So please, I guess maybe next step is to write caps, I guess. Is that right? Or do we need more discussions around how to do it?
No, it's prototype together, I think. Before we should have a prototype. I have some notes in the doc.
Yeah.
This doc, I'll put it in the chat.
Yeah, Corentin has a doc. We have a steps to get to a cap. I think there are a little bit steps before we can get to the cap. We need some a little bit more definition of the plugins, and hopefully we can get some POCs.
Sounds good.
Yeah, let's move on maybe to the, I think we're good with statuses. Maybe Mike, if you wanted to give MCS, and the other Mike, we can move to your hand if you want. Well, Mike's preserved, maybe go.
All right. I just wanted to know, and you can tell me if there's a doc I should read instead, if there's any kind of a vision of what sort of credentials we're talking about. I mean, there's lots of ways to get that kind of wrong and kind of difficult to get it right.
any kind of credentials. You should jump in the doc I just shared, and I'll share some more with you.
Maybe we need to also check with SIG auth to make sure that we're not doing something crazy.
We'll have to at some point for sure. Yes.
All right, thank you.
Yeah,
Yeah.
we've already spoken to them, but we'll need to circle back.
Yes. Stefan, you should take this back. I didn't want the updates to take too long, so I want to go.
No, that's fine. Yeah, I've got. If you look at the backlog, I have an item on my to-do list to add a scrubbing section to every call, and this is exactly that. But next time with links to the PRs and so on that we need to discuss. So thank you very much for bringing that up. So next, Babak, your turn.
Oh, yeah, that's probably for my suggestion about forming a committee, kind of. Is that right?
Or squads.
No, I'm not looking at the notes right now. Okay, so the idea is that I think we should move faster. Right now, you know, we have been kind of slow in the past 1.5 years, I guess. The only major new thing is cluster profile, and that one is partially done. It's not complete yet. So what I was suggesting is that let's form a committee who are willing to commit maybe 4 hours a week or so for reviewing PRs, you know, engaging with the community over chat, etc. But we want time commitment from these folks, and preferably these folks should be from different companies so that you know, other opinions are heard. And once the committee approves the PR, it's a good signal. Of course, everybody can contribute to reviews, etc. But once this committee approves and there's no other objections, we assume that this is acceptable by the whole community and we can move forward. And in that case, SIG leads, maybe Stefan, you and Jeremy can go ahead and approve the PRs. Of course, if you yourselves do not have any objections. That was my suggestion, really, to find a way to move faster, because right now we know that some of the CAPs, PRs, etc., remain in the review process for way too long. Yeah, that's the gist of it. Please raise your concerns, or if you agree or disagree, say something now. Or if you're volunteering, maybe we should have like a volunteering mechanism too. I don't know how we can do that.
Yeah, well, people have started writing in the doc, so Mike has volunteered, and Corentin had an interesting suggestion around a pillar approach with a document.
Yeah, I think it's a little bit in that realm, maybe of committee, or you know, it was one thing. And in that updates meeting, maybe having the streams and or pillars, and each one of them can kind of like report status and push for items in its own area, and that way it wouldn't feel as overwhelming to join SIG Multicluster, because we're very, very broad and it can be overwhelming, whether it's like networking or if you're interested more in the inventory or maybe more the UX or the scheduling, or depending on what you're interested in and what your use case, you might want to contribute to a more narrow focus. So that was trying to give a little bit of an opportunity for that without adding more meetings and without taking away from this central multi-cluster visibility and agreement and oversight. So there are some AIs I put in the notes for that I put in that pillar doc. Let me know if I could attribute them or if you want to take them. And Stefan and Jeremy, if you're okay with it, we could go with that for.
Yeah, I wondered what you meant by AI, but action items and not.
Oh yeah, sorry, that got it. The old school AI.
Yeah, Laura, you've got your hand up.
Hi. Yeah. I just wanted to mention that, yeah, in past meetings, Stephen in particular, I feel has invited people to review anything, even if you're don't have approved status or something like. And I want to boost what Stephen has said before, like your comments are still very valuable. And also knowing that other members of the community have taken a look at something, and even if you don't really have a comment, but if you're like, yeah, I'm into that or whatever, like that's still valuable. So if that's because an emoji react or a GIF that you put on the PR, or you just say, hey, took a look, I like it or whatever, I think that's also really valuable and is in particular valuable to the leads who can't like necessarily keep track of everybody's individual psychic thought process about everything all the time. So yeah, I definitely want to boost on that. I think, Bobby, what you're saying is for something a little bit more formalized and more structured with either more check-ins or more like expectations. So yeah, I think if there's like an interest in that from people of something more structured, or if you feel like you would review more if you had some more context or some more like help. Maybe a first step could be if we make like a group thread or like a group like side chat or something on the Slack so that we can at least like keep in touch. I know like, everything is kind of a little bit distributed, and adding a Slack thread might also add to it more, but that is just another idea of how we can go from what I feel Stephen has said in the past, which is more of a like, general call to action, what Bobby might be suggesting now.
Yeah, there are a few hands, but my idea also comes from the fact that there is some power and responsibility. The responsibility is in time commitment, because we want people to be able to review things in a timely manner. That has been missing to an extent in the past. So I don't want to go further. There are hands up, Richard, maybe.
Hey, this is Li Qian. I also want to support Bobby's proposal. I feel the committee has been making slow progress. As a result, different cloud providers like Azure or GK using their own MCS APIs. And then in terms of the new class profile API, it has been probably more than a year, and it's still in its early stage. I feel that it would be great if we can form a formal committee, not ad hoc ones, so people are committed to provide feedback timely so that we can reach next milestones very quickly. So ideally we can reach consensus within the community. However, as we all know that design are very opinionated, and there's no way we can reach global consensus or alignments. So if we want to make progress, we have to make decisions and move on. Otherwise, we will always delay the making of decisions, then the decisions are never made. Thank you.
Yeah, thanks. So yeah, I agree with everything that's been said. One thing that I've said in the past I think is important is to create more, well, this might sound off-putting, but more accountability so that people do think, wait a minute, this week I was supposed to spend 2 hours on SIG MC and I haven't. Or there are all these PRs that need to be reviewed. And so scrubbing was an idea to do that. I'm wondering if here we're not sort of tending towards more having working groups, which is an official way of doing all this in SIGs. And it can be fairly lightweight to set up. Jeremy would know more about it than me. Yeah, go ahead, Jeremy.
Yeah, the working groups are generally supposed to be more project oriented, and this is kind of more nebulous. I don't know if we need a formal Kubernetes structure for this, but I do think I think it's a great idea, and Stephen, combining this with the scrubbing, perhaps this group of volunteers can kind of drive the scrub, and maybe the scrub ends up being an update for the things that were scrubbed throughout the week, which is probably even better. But I love it. I think it's great. And we can come away with AIs for leads, and ideally probably also expand numbers of approvers, so that some of these changes can just kind of be more, this is what was approved this week instead of this is what needs to be approved. But I think this is a great direction.
Yeah, because there's one thing too I don't want to see happening is, and I mean, well, Jeremy and I have been discussing this for a while, adding other people, tech leads and so on. One of the things that I don't want to see happen is things being reviewed and then going through another cycle with Jeremy and me, waiting for, because, well, obviously it takes a while to build up trust in sort of a subgroup, so that we can just blindly approve stuff. And I don't think that's really the point of having approvers. So we need to work on that. But yeah, I do think having action items and being able to put people next to them that aren't necessarily Jeremy and me would be great. Yeah, another thing too, though, to point out is that some of these topics have taken a while. So I think, for example, cluster profile could have gone in more quickly, or we could have split it up. But there are things that we only realized after quite a long time. Like, for example, the credentials, all the credentials work. We thought we had a decent solution early on. It turned out not to be so great. We came up with another one that also turned out to not to be so great, and we're sort of switching back towards something that looks like the initial one, but it needs to be refined. And then there's the plugin idea came up. Same goes for on cluster profile, having the ladder approach for how fields get added to cluster profile, or well-known key names. And that, I think, is important, but we only realized it fairly recently. But I will say, the one thing I've noticed since coming back from PTO is that there have been a lot of conversations on the Slack channel, which is also great. It means I have a lot to catch up with, but that's fine. But yeah, so I like I haven't looked in detail at the pillars document, but I like the idea, and I do think if we can have more people committing to dedicating more time, things can only get better. But anyway, yeah, APAC, no update. And so I think too that APAC is an important ingredient for all this as well, because there's a lot of stuff coming in from that's actually implemented, for example, in Karmada or OCM. But we've had to find it difficult to get traction from people on those projects, and that's no fault of theirs. The time zone issue is a real problem. So hopefully things can improve once we get that set up as well. But I don't want to take too much time away from Rafa, who's got an interesting demo for us coming up next. If nobody else has anything to add to this particular topic.
Hello, guys.
Yeah,
I'm sorry, I didn't raise the hand because there's no button here.
Oh.
So
okay, yeah.
I'm Honghai from the Kamada project, and
Welcome.
basically I agree with the idea of Babak. I'm not sure I'm pronounced right. So I think we need some more approvals to review PRs or caps offline, and so we can make a quick decision on the weekly SIG meeting. And one thing I think we, there are a lot of, there are some of projects in SynSafe like Kamada, OCM, and Fleet Manager, and MCO, right? And so I think it's important to get those guys involved for anything for prepared proposals talking in this SIG.
Yeah, definitely. Yeah, thanks for that. Yeah, I agree. We definitely need more involvement from people in all those projects. Right, so thanks everybody. Rafa, if you're there, do you want to?
Yeah, I'm here.
Present your demo. You should be able to share your screen.
Yeah.
Yes.
Okay, thank you. Let me share here. go to this slide. Okay, my name is Raffaele Spazzoli, and today I would like to show you an idea, okay, and see what your reactions are to this idea. I work for Red Hat, thinking about the multi-cluster for product, and I'm in consulting, so I have to implement that product, and I see the issues that we encounter. So I would like to talk about the current traditional hub and spoke setup that I see in many multi-cluster approach. That's not just Red Hat's approach. I've seen it in many other patterns and products that have to deal with multi-cluster. And then I would like to present an idea and see what you think of it, and perhaps do a demo. So if we look at what the traditional hub and spoke approach for multi-cluster is, there is a hub cluster, right? And then there are some agents, and then there are spoke clusters, and then there are some agents, and these agents are little operators that implement some behavior, right? It doesn't really matter what the behavior is. In for Red Hat is a very complex product, but it could be something simple. It doesn't matter. And so what these operators do is that they watch the local control plane and they watch the hub cluster control plane in some shape or form, right? And then they do whatever is their task, right? And that's more or less what how multi-cluster is implemented in many cases, at least what I've seen. I haven't participated too much to multi-cluster SIG, so perhaps I'm missing something, but this is what I've seen most of the time. And if we think about what really is happening here, is that what's happening is that we are using the hub control plane, in particular part of the storage, right, to share some share state, okay, or some state that needs to be visible to the spoke clusters, to the managed clusters. So there is a little bit of conflation here in the control plane of the hub cluster, because it's used to run the hub cluster, but also to store some of the share state. And this architecture, over time, I've seen it as this. It can be easily, I think, figured out, but in my experience, this architecture has this problem. First of all, the hub cluster is a single point of failure. So if I lose this cluster, if it becomes inaccessible, these operators cannot do their job, and this may or may not be important, right? It depending on what they're doing, right? Sometimes you cannot deploy new applications. Sometimes there is an actual impact on the existing applications. Second problem is these operators are hard to write because they have to watch different control planes. So, and the Kube builder and other frameworks don't really are not designed for that. And I know there are projects now coming up to try to fix this problem, but in general, I myself had to write an operator like this, and it wasn't simple. And then this architecture is not very scalable. So beyond, let's say, 100, maybe 200 spoke clusters, you can't really use the same. You can't really use a single etcd to share all the shares, to store all the share state. Etcd can only grow up to a certain point in our experience, maybe 4 to 8 gigabytes of storage. Beyond that, it doesn't really scale, and mostly because it's a single partition database. Okay. All right. So I tried to imagine what could we do to solve these problems. Okay. All right. So here is what I imagine. This is my idea. So it's a bit complicated. It's a bit complex. So let's take it apart. I will explain piece by piece. Okay. So first of all, we have a this fully distributed database that can be stretched across multiple failure domains. Okay, so let's imagine that we have at least 3 clusters in different failure domains. So this could be different data centers. And we can stretch a fully distributed database on top of it. Okay, so I have Yugabyte here as an example. There are other options here. You can do TIDB, you can do CockroachDB, and probably there are others. On top of it, you can have Kind, which is a shim that exposes a SQL database as an etcd API. And then we can have an API server, okay, which whose task is to serve this, which is going to be the share state, right? Is to serve what is in this storage. And then we can have the local API server with an API service. As you probably know, API service is a standard Kubernetes API to essentially configure a proxy in the API server and say, if you see an API request for this domain, don't serve it locally, but forward the request to somewhere else. So we can say that there is one or more API domain that is the shared API domain, right? And so if you are requesting something for that API domain, you get routed to the share state. If you're requesting something for the local that is not in those API domain, you're requesting something for the local state. Okay, so we can build this. So now we have a namespace, an API namespace that is dedicated to the share state, and then the rest is local. But now we can write operators that watch a single API server, right? And they can simply, depending on what they watch, the operator writer needs to know, developer needs to know that is dealing with a local state or a shared state. Then we can add a load balancers and a global load balancer to make this shared API server accessible from other clusters. So we can we don't need to extend the database to the other clusters, but we can have more clusters observing this shared state if needed. Okay. Before I explain why this should solve all the other problems, do you have any questions?
I don't know who is
Mike was first. Go ahead, Mike.
Go ahead.
Yeah, first I'm kind of wondering what you mean by shared state exactly, and what these operators are doing. I'm also surprised you seem to have shifted where the operator runs from in the managed cluster to in the hub.
So in this architecture, there is no hub. So maybe I mis-explained something.
Oh, I see. It's just all the managed clusters symmetrically, or maybe not.
All clusters are clusters that run workloads, and they're not play any role of being the hub. Some of them carry the share state. We don't need to have the share state stretched to all of them.
So maybe I should back up. I'm not quite sure I understand what you mean by shared state. And I want to back up. There's really kind of some basic questions about, some people make assumptions about what they mean by multi-cluster and what they're trying to accomplish. And there are different answers. So one form of multi-cluster is, I'm trying to give the illusion of one big cluster. Another form of multi-cluster is, I want to manage a bunch of independent small clusters. Can you explain kind of where you're falling on that, and what kind of shared state we're talking about?
Yeah, I'm trying not to make any assumption about that, because at the end of the day, whichever problem you're trying to solve with this multi-cluster, and I agree, those are two of the usual types of problems. But whichever problem you're trying to solve, there is a state that more than one cluster have to be able to observe. So that's the shared state. Okay.
Well, so let me break it down a little bit. So I've been focused on the case of, I want to manage a bunch of independent clusters. And in that case, I make the usual Kubernetes distinction between desired state and reported state. So I'm thinking about the case where for a there is a hub cluster where it is declared what desired state goes in what managed cluster. It's distributing workloads. It's prescribing what workloads run in which of the managed clusters. For each of the workload objects, it needs to be described only once. It doesn't need to be multiplied by the number of managed clusters. On the other hand, for reported state, that does need to be multiplied. And if you can't in a Kubernetes cluster, or in general, the idea of propagating all the reported state from the managed clusters back to the hub as you scale up just becomes impractical. So I tend to think about you doing some reductions on that reported state as it moves back towards the center. I also tend to think about hierarchy, which you haven't mentioned, but I'll stop here.
Yeah, so let's take this use case, for example. So basically what you said is, I describe my desired state for all of my clusters in the hub cluster. And then you probably have an agent that is observing this state and says, okay, there is a very large description, but I'm really focusing on what I need to do in this particular cluster, and I extract that information and I deploy it here in this cluster. Okay, basically this is reading the share state, right, and decide what to do in the local environment. So you can still do the same thing here, right? Something deploys the shares, the desired state for all of the clusters in this share state. Okay, and then the local the operators here, they look at the share states and they make local decisions. It's the same thing, right? You cannot use exactly the same APIs. You will have to model them, right, to work with this pattern. But you can absolutely achieve the same. In my opinion, at least, you can achieve the same result. Okay, and so that's what I'm trying to say. I don't want this to be problem specific too much. You should be able to use this approach to solve any problem in which essentially multiple clusters have to watch a state that is shared, and they have to make, based on that desired state that is shared across them, make local decision. Right.
All right,
I think there
Babak.
was another question.
So yeah, let me my question is somewhat similar to what Mike asked. Let me actually give you a couple of very specific scenarios. Maybe we are not understanding the whole thing clearly. So one scenario is that with a hub cluster, a user of a multi-cluster environment can interact with one API service endpoint, which is the hub cluster. For example, they can create a multi-cluster deployment, and the multi-cluster deployment, they talk to that single point. I know that it's a single point of failure, but it's also very convenient for the users to always talk to that one endpoint. That's one. I don't know how it's exactly working here. I guess maybe they can talk to one of these clusters and it's replicated in all clusters. The second scenario that I wanted to see is that when you're interacting with that API, hub API, you may create a multi-cluster deployment, for example, but the multi-cluster deployment does not necessarily go to all clusters. You can specify things like, okay, I want this deployment to be at least on 3 clusters, but if those clusters are out of capacity, etc., I want it to go to other clusters and so on. So the point here is that not all clusters have the exact same deployment. At different points in time, they may have that deployment or not have it. So a controller running in these, in the shared state cluster, how do they know if they should be operating on those, objects in the shared state or not?
Right, I got it. Okay, so first question, you can talk to any cluster and deploy something, and if you have the right permissions, you can create an object in the shared state. Okay, doesn't matter which one. Second question, if you are in this scenario and you create a, what did you call it, a deployment, distributed deployment or something like that?
Yeah.
Can you give me the concept again?
Multi-cluster
Multi-cluster deployment. Okay, you create a multi-cluster deployment. Probably in that API or an associated API, there is a cluster selector or a placement concept, right? And then, so everybody can see that there is that, all of these agents can see that there is a multi-cluster deployment, but they decide whether it's relative to the cluster that they control.
No, not necessarily, actually. So what you are describing is what we call it a pull model. Basically, all these agents exist on the clusters, and they pull it from that API server, the hub cluster API server. Another architecture is a push model, where there is no agent on these clusters. In fact, in MCO that we recently announced, we are using the push model. So the hub cluster decides at what point in time write the single cluster deployment to each one of these individual clusters, and sometimes it deletes it too. So there is no agent, there is no pulling mechanism. It's the hub cluster that decides.
Okay, understood. Okay, so in your scenario, there is an agent, there is an operator here that is actually connecting to all of these control planes and making decisions directly to those control planes. Yeah. No, that architecture, it just doesn't scale. So we, yeah, I don't even, I haven't considered it, but I acknowledge it exists. That's true. Okay, so I don't have. I mean, you can try to recreate it here, but it's not the problem I'm trying to solve. It's just something that we saw doesn't really go very far usually.
So I guess I'm next in line. I was wondering that because the hub cluster spoke structure, right? It's essentially the same as the API server and Kubernetes structure in today's Kubernetes design. So it should be as scalable or as unscalable as Kubernetes. Basically, it can go to thousands of nodes. If you think one workload is a pod, one workload in a cluster is a pod, rather than like need to report the status of each pod up. So basically, it can go to thousands of, as we already know, it can go to tens of thousands of nodes in this in this model. Basically, that's the scalability of Kubernetes. Then I think there's another problem here. Maybe you already solved it. Like we often need a multi-class scheduler to decide where the workload should go to, because it will not go to every cluster. Then you need to have something somewhere who's running the scheduler, right? That is still basically you need to have a single instance of scheduler that makes decisions. And I think this in your model, it's very interesting that you use KIME and you basically deploy a pod of an API server, hub-based server into each cluster. But that also means some probably waste of resource. Why don't you like pull them up, like having multiple like your shared state API servers, then they are back to this King and whatever database you have. It should be as scalable as your data structure, because now you require one-to-one mapping between each member cluster and the shared state API server.
I'm sorry, I do not understand.
So, I mean, like you can make the shared state API server multi-region deployment instead of deploying into, like, basically they can be extracted out, still making a hub cluster. Then that means the number of copies of shared state API server is independent of the number of member clusters, right? Like, do they?
Okay, so what they're saying is, you're saying you could extract these outside.
Yeah.
Sure, that's fine, but why? I mean, it's easier to deploy stuff in Kubernetes. That's why I'm deploying it here. But yeah, conceptually, you could extract it outside. The point here is, I have stretched the share state across multiple failure domains, so I don't have a single point of failure, right? And I've used a fully distributed database. So one of those databases that have the concept of partition, So I can essentially scale indefinitely. And it doesn't matter. So here you really, I mean, these databases, they go well beyond 4 gigabytes or 8 gigabytes, which is kind of the limit of TCD, right? Of course, when you stretch a stateful workload that needs to be fully consistent with all of those ACID properties, you accept a little bit of latency, right? So this control plane, this part of the control plane is not going to be as snappy as the local etcd, but it's going to be as consistent and can scale infinitely and indefinitely, let's say. And I don't fully, of course, I don't know all the use case for multi-cluster, but the things that are in the share state typically don't have to change that quickly. Like, you know that etcd in Kubernetes has to be snappy because namespaces, pods, replica set, those config map, when they change, they have to be, you know, they trigger a storm of other changes and everything has to happen very quickly. But the things that we are going to, the typical concept, I think, that we're going to describe in the share state, they don't have to change that quickly. So I thought having a little bit of latency on the share state is probably acceptable. Okay. As far as taking this portion of the architecture and deploying it somewhere else, that's fine. It doesn't change to me. For me, it doesn't change the main concept. I deploy it here because I think that in general, we want to use all of this capacity also for running normal workloads. You know, one of the problems that I don't highlight here in this architecture is that this cluster is not running application workloads. It's just here to coordinate the other ones. And it's typically I don't want to say significant, but it's typically a waste. We have constant discussion with the customers on whether it is actually worth having a hub just to coordinate the other clusters. So this would solve that minor problem also.
Yeah, my suggestion of separating that is based on our, like, usually when we run production, we want to separate our control plane from customer's data plane so that we can ensure reliability of our own control plane to avoid being to avoid noisy neighbors from customers' own applications that will affect the multi-cluster orchestration.
Mm-hmm. Okay. Yeah, I mean, that could be an issue, I guess. Meaning if the customer is somehow, or if the tenants are somehow generating a denial of service on this API server, you also cannot reach, obviously, the distributed control plane on this cluster. But by the way, this path is still available, right? You cannot interfere with this path. But yes, in this path here, you could. Yeah, I would argue that you have to solve those problems in a different way. You actually have to protect your control plane anyway from the tenants. But point taken.
Just a quick time check. We've got less than 15 minutes left. Okay.
So just quickly, there is a single point of failure. I hopefully have convinced you of that. An operator, now it's easier to write operators. You just have to be aware of the fact that certain APIs are local, certain APIs represent share state. Fully distributed database, if you pick the right one, will essentially scale indefinitely. Now, one issue that I found building this architecture, because I wanted to have something working, I wanted to demonstrate to myself that this was actually possible, right? What I found is that I couldn't find anything to play this part here. I was hoping to use KCP, but actually KCP, sorry, let me back up. To do this part here, you need an empty API server, right? Empty as in it doesn't know anything about the Kubernetes, standard Kubernetes API. It's empty. And you can fill it with CRDs that represent the share state. And as the developer of operators are deploying new operators here, like I said, we don't know what people will want to do with multi-cluster, right? I couldn't find anything that can play this role that it was already made. Okay. So for the demo, I just used an API server here that is actually built to serve some specific API as not general purpose. But if we like this idea, I'm here to collect feedback, right? But if we decide that this is an idea where we should invest on, then this is certainly a part where we could say we should create a component that is just an empty API server and can be used to play this architectural role. Okay, so I can show the demo. The demo is actually very short, but I'll show the demo. I have here 3 clusters. So you can see kind one, kind cluster 1, kind cluster 2. Sorry for the messages, and kind cluster 3. And I have this festival API. This is the API that I found in this pre-built API server that I reuse for the demo. Okay, so I have this festival API, and if you see, if I do this get, I see the same thing from the 3 control planes, right? Because this is in the share state. Now what I'm going to do, well, I have the clusters here. You can see that they are running. There is Yugabyte here. I use Cilium as the CNI, and I use Cilium Mesh. It's called Cluster Mesh to do the east-west traffic, right? Because this part here requires that this to stretch a distributed workload, you need east-west traffic between the clusters. And then what else do I have? I have this API server here, which is the one that I just found and I just built for this demo. So I have this 3 cluster. By the way, I built the demo in such a way that anyone should be able to run it on their laptop, right? So I have the instruction in the repo where if you care about this architecture, if you want to give it a try, you should be able to just follow the setup and get it running very quickly. Okay. So what we're going to do in this demo is I'm going to connect to one of these clusters, create another manifest, and we should see that it appears almost instantaneously in the other ones. I say almost instantaneously because I'm using a watch here, so it's every 2 seconds. So if I do kubectl, let's say context kind cluster 2. I always use cluster 1, so I'm making it difficult for myself now. Hopefully it will work. I'm gonna go to API server samples festival 2. Okay. So when I give this command, as soon as these 2 seconds refresh, we should see the new API, the new instance of this API everywhere. Boom, boom, boom. As you see, it was created. So you see, it just do what I have described. It was gonna work. It was gonna do, right? How it works. You can create some state talking to the control plane of one of these clusters, actually any one of these clusters, and then the state is stored in a shared state, so everybody can observe it. From there, build any operator that you want. Now, some considerations, right? First of all, like I said, I couldn't. I was hoping to use a KCP, but KCP didn't work for the shared state API server, so something has to be done there. I think there needs to be a way to elect a leader between the operators across clusters. So probably using the same method that we use in the local cluster, but the lease API should be also a share state lease API, right? And then we need a way to apply new CRDs to the shared control plane, because if we want to make it easy for developers to develop multi-cluster operator, then they can just bring their own CRDs, just define somehow that those are shared state CRDs, and they become available. And that's all I have.
I think for the hands, I think it was Mike, then Babak, then Owen.
Yep.
All right. Let's see. I wanted to understand what went wrong with KCP. Is it because it has a built-in binding to etcd? No, the kind still supports that. Yeah. What went wrong with KCP? I said so 3 points. I wanted to understand what went wrong with KCP. I wanted to point out that the need for a multi-cluster scheduler, that depends on the usage scenario. I think when you have policy-based management of a lot of managed clusters, it's the author of the policy that's making decisions, not a scheduler. And I wanted to ask again about reported state. It's one thing to distribute desired state, but typically in multi-cluster scenarios, you also want to gather some reported state.
Okay. Yep. I don't know that I have answered to everything, but let's talk about KCP. So KCP, I can't recall now exactly, but it essentially makes some assumptions. I couldn't use it directly. They have a concept of a proxy, but then with the proxy in front of the KCP itself, it doesn't really work.
Indeed, I've used KCP without the proxy. I mean, that was a couple of years ago, but at least as of then, you didn't need to use the proxy.
Okay. I tried to make it work. I still have them. I think I still have the manifest where I tried to make it work. If you want to help me give it another try, I'm open to that, because that would help a lot. Then the second question was, one was the reporter state, and what was the second question?
It was just actually more a comment for someone else who was talking about you need a scheduler.
Yeah.
I think so. Yeah, but anyway, yeah, the question for you was about reported state, but also on KCP. In the project I'm working on, Kubestellar, we've developed another alternative. We have a thing called Kubeplex, which can create a variety of kinds of or types of control plane. One of which is pretty blank, and we use it for our workload description spaces. So that might be also a source of something you can use. I also know that KCP spawned some work upstream on creating a generic control plane. I haven't paid attention to that in several months. I'm not sure where that's at.
So I didn't capture your name, but can you ping me on Slack, and then I will come back to you with. Yeah, I want to explore all of these alternatives. They sound very good for the problem I'm trying to solve.
Okay.
Yeah, on the scheduler, I think I'm very well aware of the problem of AI and these distributed schedulers. I think this could help in that space, right? Because I can create a share state manifest that declares the intention of scheduling a job, right? And then each multi-cluster, each local operator can understand what the job is and take only part of it, right? And schedule it locally. Or maybe there is an operator that breaks the job request apart into many, and then the local operators understand what needs to be done. And
well, if you're talking about training jobs, typically you want all the tasks in those jobs to be gang scheduled and run in the same cluster.
Okay, so anyway, maybe there is a way on reporting. So maybe I don't fully understand that space. In my mind, it can probably be broken in two pieces. Let's take the example of a global load balancer. That's actually an operator that I try to write in a multi-cluster setting, right? So let's imagine we have an application, right? And we have ingresses defined for that application. We want to create a global load balancer operator so to configure a DNS, for example, to load balance onto those ingresses. Now, we could create a share state global load balancer desired state, right? And then the local operator can see that there is a match between the ingress and this desired state, and they can report to the status of this CR. I'm hypothesizing here, right? My ingress VIP is here, right? And then through leader election, one of these agent becomes the leader, and looking at the statuses that were reported, can go and configure the DNS, right? We only want one of them to be the leader that make the actual configuration. But maybe all of them can do the reporting of the local status if the local status is needed to make a global decision. Okay, so that's one use case. The other use case is to build dashboards, to build multi-cluster dashboards where I have to report everything, and I'm not sure exactly what's going to be useful. That's where probably we may need a different type of. We cannot use the status here. It's going to be something else, right? I'm not sure how, but what I know is this database. You can store an unlimited amount of data in this database. So we're not worried about running out of status of capacity of the database of serving those kind of requests. But how to do it exactly, I don't have an answer.
Thank you. We're out of time. I really need to tell you guys about Kubestellar. I'm going to sign up for next week.
Okay, so I'll stop sharing.
Yeah, I think unfortunately we're out of time for the rest of the questions, but it does seem like this is a hot topic. So happy to invite you back for some more convo or talk on Slack. And it sounds like you've been able to make some connections here with some feedback and projects. So
yeah, that was
cool.
Great.
Thanks a ton for sharing.
Thank you. Thanks.
Yep. Thank you, everybody. See you next week.
Bye.
Thank you.
Bye.
Thank you.
Bye.
Bye.